start. So hi, I'm Maciej, engineering manager at 3M Dev. Today we'll talk about TrenchBoot and QubesOS as solutions for QubesOS anti-evilmate. So we'll start with a very brief introduction for what is QubesOS anti-evilmate and TrenchBoot. There's been many presentations about that before, so I will link you them in a moment. All of the links are clickable in PDF. If you go to the CFP, you can download and click all of the links that will be in green in the slides. So after the very short introduction, we'll focus today on the hardware requirements. So we want to have another look on what is required from the hardware to even try running this TrenchBoot solution. Then we are working on a way of simplifying testing and actually testing TrenchBoot on hardware. We want to create a compatibility list to explain users which hardware is tested, supported by the solution right now. And we finalize with project status to showcase what has been completed in the last months and what are the future plans. So as I said, there's been many presentations. Those are not all of them, but those are the typical statuses we've been giving in the previous QubesOS summits as well as FOSDEM. So if you are interested in hearing more, please go back to them. So very briefly, what is QubesOS anti-evilmate solution? It's a set of software packages and utilities with the goal of protecting against evilmate attacks, and I will finalize here. And what is TrenchBoot? It is like a technology that we use in this QubesOS anti-evilmate solution to provide us with the DRTM technology that we need for this solution. TrenchBoot is a project which is open source, community driven, but mostly leading by these three companies. So let's start with the hardware requirements that we want to deep a little bit more today. So there are two main ones. The first one is TPM, which is a bit easier nowadays. Typically, we have like FTPM in many CPUs today, or chipset, depending on the platform. So it's like a firmware TPM, but we can also have like a DTPM, which is a discrete TPM. So it's an additional add-on board inserted on your main board. And the second one is the dynamic root of trust for measurement. So we'll call it DRTM. So it's a technology from a silicon vendor. It needs to be present in the hardware that we want to run our solution on, and needs to be properly supported by the firmware as well. So let's focus on the DRTM today. So we can choose from Intel or AMD today. To have this one for x86, and for Intel we have it provided via the senter CPU instruction, which is provided with the TXT Intel Trusted Execution Technology. For AMD, it's the SKInit instruction provided as part of the virtualization instruction set. So for Intel TXT to work, we have to meet several requirements on the hardware level. So it's not only like a one part, it's like a whole platform that needs to meet those requirements. So we have the CPU, which must be TXT capable. We have the chipset, which must be CPU capable as well. So we often may end up in a situation where we have the CPU, which is capable, but chipset is not, so the platform itself is not TXT capable. It needs to be properly supported by the firmware. We need to have like proper setup. There are several ways. There are several actions that must be taken to configure it properly. And then from the user perspective, he often needs to also go to the BIOS and set up the VT virtualization, VTD, TXT, a bunch of options before even trying to use that feature. And even later, maybe there is also a need for this ACM blob for Intel that must be either provided in the firmware, but maybe it can also be loaded later, as we will see from the grab in our case. So there are a lot of requirements to meet here. In case of the AMD, it's a bit simpler because the SK init instruction is essentially part of the virtualization instruction set nowadays. So basically, any AMD CPU and AMD CPU platform should be DRTM capable nowadays. So can it run TrenchBoot? So we know what are the requirements. And once all of them are in place, can it run TrenchBoot? Maybe. Definitely, if any of them is not met, it won't run TrenchBoot. So that's for sure. But if they are all in place, we may have a chance, and we should try it. And the only way to know for sure is to simply try. And we may end up with some failures, different failures like undocumented TXT errors, different reboots. One of the platforms had like, if you boot with Zen normal, you have the TPM. If you boot Zen with TrenchBoot, DPM disappears. Different weird problems that need further debugging. Maybe there is something to be fixed on the BIOS side, but BIOS is often provided by vendor. If you don't have update, you're out of slack, or you go to the shower. So how do we try that complex stuff? Because you have several components that you need to assemble to have this TrenchBoot going on. You have grab, you have Linux, you have Zen. There are different patches, different branches. It's all in the ongoing development, right? There are also some components from Intel, like ACMs, that might need to be used. So for this purpose, we have this Meta TrenchBoot project. It's like Yocto Meta Layer, and we can use it to assemble an image containing all of these TrenchBoot components from some integration branches that we have selected right now. And as a result, we are getting a single USB, not USB, but a single disk image that we can flash onto a USB stick, for instance, go to the platform, boot, and see if it works or not, right? And it's supposed to be as generic as possible, so it should boot on legacy, UEFI, Linux, Zen, based on what option you select in grab. So MBR, GPT partitioning scheme, Intel, AMD, and so on. So it was supposed to be one to rule them all. Then on top of that, we are adding like a script. We want to gather some more data from our users, to have some hardware compatibility list. Right now, it's heavily inspired by the QubesOS. I mean the script and the format. So we are gathering some critical hardware information that we need here. Just a few of them listed in this slide. Also, we are gathering a bunch of logs that would be helpful in case of failures, which may be more common today than we would like to learn some from these logs. Maybe something can be done on the TrenchBoot side to make it work on the platforms that are not supported today. Or maybe it can be used as some suggestions to the users that what's wrong with your platform. Maybe you can do some stuff to also make it compatible. So apart of the standard Linux logs, like Linux Zen TPM logs, we also use tools from the tboot project, like the TXT stat. Also, there is like Converge Security Suite and TXT Suite Specifically, that we find here somewhat useful. There are a couple of problems that it cannot be built right now, and the latest versions didn't work for us, but there is some older one that does, and does produce some useful results to see if the TXT configuration, mostly on the firmware level, is correct, and maybe what's missing, and that can be also helpful during possibly implementation of TXT in the Sharo, if we will go with that. So that's a subset of tests from this TXT suite. In this discussion in GitHub, we are actively narrowing down this set for the most important ones that we need to take care for in our use case. Some results for the latest meta TrenchBoot image, and it's important to say about this meta TrenchBoot because the TrenchBoot itself is like a broader. There are a bunch of branches, patch sets. One patch set is more focused on Linux, one patch set is more focused on AMD, and so on. So we have some integration branch which is baked into this meta TrenchBoot image right now. It's mostly based on what we've been releasing on the latest anti-EV made. So we had like a bunch of older AMD, bunch of newer AMD, bunch of older Intel boards, newer Intel boards, one server board, a laptop, thin clients, workstation. So not that much, but a few different kind of hardware. What are the solutions so far from that? Definitely the older AMD boards have the best support in our integration. Right now, it's maybe obvious because we as FreeMDeb specifically have been mostly focused on that for the last couple of years even. We don't support modern AMD, so to speak. The modern, we estimate it's like Zen and newer, but I'm not sure if we are certain at this point. But basically, there is like a new DRTM flow for these boards where PSP is more involved. And there's been some work actually by Oracle for servers in that regard, which is not integrated in our branch right now. So it would need to be integrated and applied also to modern clients for AMD. As far as we know, there are some differences. So, but maybe based on the work by Oracle, we can make it a bit simpler. To support both the older and newer AMD flow, we need proper integration of Intel and AMD Linux patches on a single branch. There is a Linux TXT series on the Linux kernel mailing list, which I suppose works on Linux because it's tested by the ROS who contributes that, but on our case it doesn't, so maybe we don't use the latest one, or maybe our AMD changes introduce some Intel breakage, but the essence is that the integration we have right now doesn't work on Linux on Intel right now. Yeah, because we've been mostly focused on AMD, and Intel Linux was mostly on Oracle's side right now. Definitely, we need much more testing, especially on more modern boards. In case of Intel, there is like this vPro Essential. I think it's from since Alder Lake probably, where there are possibly more CPU chipset options that might support TXT, which is a possible sign for broadening the availability of this feature, which might be interesting. Definitely, we don't have all the hardware in the world, so we could use some help in reporting those HCL, testing on your hardware. Maybe we can use also some of the hackathon tomorrow, if you would like, to see if you can run TrenchBoot. some failure examples. That was from this ASRock server we are working on right now. It's stock firmware from AMI, so no Dashara. And yeah, when selecting Zen, you just end up with this screen forever. There is no serial logs, so maybe we need to further investigate that. But that's just one of those problems where supposedly all of the requirements are met, but it doesn't work.
We think we fixed that bug in Zen staging.
Okay.
It's not TrenchBoot related.
Great. So the one I was talking about, this Lenovo tiny, just TPM device disappears, and very, very weird kind of problems. You boot Zen, normally it is. You boot Zen with TrenchBoot, it boots to DOM0, but there is no TPM device. So I don't know at which point it's lost, but definitely on Linux it's not visible at all. And with no TPM, there is no DRTM. So how, if you would like to contribute, how to do that? Just follow the README in the repository. Oh, I broke some. No. Just follow the README. If you have any problems, you can contact me. For the improvements ideas, we thought maybe there is still some friction that you need to upload a pull request. Maybe it should be just like press enter in this image, but that would simplify that, but it would mean we would need to store them somewhere else probably, because GitHub wouldn't allow anonymous contributions. So maybe that's something to consider to simplify and possibly get more results. Project status. So it's what we have completed since FOSDEM, so since January, February this year. So we have completed phase 4, which has been funded by AMD, by NLNet Foundation. So we have full support, as we don't see not full, but for this older AMDs, we have this support integrated, and with this new approach. And most importantly, we have the UEFI support, which was lacking last year. So the hardware compatibility right now should be greatly improved because of it's mostly UEFI today. So in the last summit, Michał was trying some demo with laptop and CBIOS, which was a bit stretched, perhaps. So today, it should be much easier to find a hardware that we can run TrenchBoot on, actually. In terms of upstream, it's a long story. It started back in 2020 with first Linux and grub patches. A patch series submitted to mailing lists. Right now, Linux is on number 14, grub number 4. Why is that? There is some relation chain that we saw in the process. The Linux Intel series was first one. Basically, in the grub, we hear that we need to have Linux merged first before even we talk with the grub to have it merged. So that's like a prerequisite for grub. We need patches in Linux to be merged. Then we can go to grub and merge patches in grub. For the Linux AMD, we need to first merge Linux Intel, then we can merge Linux AMD in Intel. And it's been already 5 years on Linux Intel of development and also consecutive patch series. With Zen, maybe it will be a bit easier. We started Zen not that long ago. We are at patch series number 3. We are discussing number 4. And my feeling is that it might be the first one to get merged from these 3 projects. Yes, for the graph, as I said, we have links for those discussions if you're interested for the latest ones, but generally the message is that we need to wait for Linux. And with Linux, it's already number 14, so a huge effort from Ross, from Oracle, to pursue it for over those last 5 years already. It's a bit complex situation right now. The maintainers are not very positive, even after those years, or maybe especially after those years. It's being questioned about at this point why are we going with TrenchBoot if we have tboot, because there is already some tboot in kernel. So why do we have this second DRTM provider? Details in this thread, basically. One of the messages might be interesting. There was like a QubesOS example, and one of the maintainers was wondering if QubesOS like is a real thing or it is just for hackers, because it was like an example of practical application. So maybe if you go with it remained unresponded as far as I know, so maybe if you go with QubesOS numbers, maybe that helps. We have some estimation on user base. Note that we don't really directly need Linux for QubesOS anti-evil mate, because we use grep and Zen, but we need this indirectly, because if we won't have Linux, we won't have possibly grep patches merged, and we will need to maintain grep patches if we want to keep with TrenchBoot for QubesOS anti-evil mate. Further plans, various enhancements. The major one should be enable modern AMD platforms. That we would like to start with that one to greatly expand the list of supported platforms. We have one of that from the past, the DRTM between coreboot and UEFI payload. That's been like hacked like a few years ago. We want to investigate it a bit more, possibly. Some others, so especially we would like to focus on broadening the hardware compatibility. If we have this modern AMD, then boards like MSI Pro, B650, and a lot more should be supported. Possibly the Sharo hardware. There is no Sharo release right now, at least not the official one that has TXT properly set up. So maybe laptops could be an interesting case, especially for this anti-evil mate, which is mostly targeted at laptops. We can see that the upstream takes a long time, so we can estimate that it will take a few more years. So we should be ready for delivering QubesOS packages for those who want to try this solution. We need much more testing and moving forward with the upstream. That would be it from my side. Any questions?
One very quick point. On an early slide, you said there was the SKInit instruction on AMD and the senter instruction on Intel. It's not the senter instruction, it's an instruction called getsec, of which one sub-function of it is called senter.
Yeah, that's obvious, sorry. Thanks.
I have a, so for this tool for testing compatibility, is it the same image for both Intel and AMD, and how you provide the ACM binaries, etc.? How does it? Is it the same for all the platform, or do you need?
Yes, we have a single image. How do we provide that? We have a grep. We have a grep trying to load all of the ACMs one by one, and at some point it finds the proper one. Hopefully yeah, that's the single image. And it tries SKL and then all ACMs, and then you get a bunch of errors on the screen, but that's expected. I want to fix that. But the current experience is that you run one of this entry and you get like 10 errors because 10 ACMs failed, but one silently succeeded. So it's not optimal. But
Okay. And the second version, I haven't seen it on the slides. Do you also include a firmware version in the report? Because I think that's useful to.
Yes, I do. It's not full. It's not full YAML here. I do.
Okay. Okay. Thanks.
Actually, can you tell me how the boot process looks like for the end user?
The boot process. So it was. No, it was here. So the boot process is simplified. Simplified. It's like usual, but you have in the middle you have like some additional component. For AMD, it's like.
No, well, I mean, is there like with HATS firmware, for example, you have a USB security device.
Okay.
Is there something like that with TrenchBoot as well, or
TrenchBoot is like only providing this DRTM bits, so it's limited to what you see here. It's TrenchBoot is underlying technology for the QubesOS anti-VMlate solution, we can say. So for TrenchBoot, there is no USB needed, but if you want this anti-VMlate, I think the USB is at least recommended. There is also some option of not using it, but yeah.
Okay.
It might be easier if so TrenchBoot itself is just a set of patches to a bunch of repositories.
Yeah. Okay.
The end result of this is that you can get an attestation quote.
Okay.
And you can either do nothing with it, or you could build remote attestation on top of it. So in the future, yes, you can get a quote out in the middle here and go and check it in some other system or whatever your policy is. This is just building blocks.
Yeah.
Yeah. So one of the things built on top of TrenchBoot is anti-VMlate, which recommends using USB stick with some sealed secret to verify. But you can also do with internal disk. You get a bit weaker security model, but it also works.
Maybe also with TOTP codes, like authenticated. Okay. One other question I have: do you think that the Intel path is easier than the AMD path of the other way around? Like, do you think
Intel is much harder? I would say.
Intel's harder.
From the hardware requirements perspective, it is. So we can say because it's it's more difficult to get a platform that would have match all of those marks. So we can say it that way. We can say also that we have this Intel ACM, which is a closed source brought from Intel, as opposed to this SKL, which is a secure kernel loader, part of the TrenchBoot project, which is open source equivalent, we can say, of this component. So from this perspective, we can say maybe Intel is a bit more difficult to have a platform and maybe less open source components.
So do you also think that AMD OpenSil will help you more with this project?
I'm not sure if that matters that much.
Okay.
Yeah. This thing called SKL is a secure kernel loader. With AMD, they just said, here's some requirements, write it yourself. It's an appendix in the main manual. Nothing else really matters, whether it's OpenSil or something closed, it doesn't really matter. I guess the difference is that on AMD it's mostly left to us and there is zero documentation. It took like 6 months to figure out why we were always getting the same hash into the TPM, no matter what image you gave it to measure, because it's not even documented what the SKInit instruction does in the case of an error, and it's extend a fixed string into the TPM. Because even that's not documented. So AMD is much more simple on the hardware level, but it requires much more complicated politics to find answers to questions we need.
Thank you.
Yeah. Oh, I have a bunch of. I'm sorry. So first of all, it's from Demi. How much is TrenchBoot tied to grub? So let's try to maybe quick.
I think pretty much right now, because this is the only implementation that we have.
It's worth saying that there are plans that wouldn't tie us to grub, but they're in the future.
Yeah.
It's not like a design tied, but it's the only implementation right now.
Yeah. Zilbalazer asking for B650. I guess he should ask for B850 because 650 probably will not be done. So this is AMD.
Well,
desktop.
it doesn't matter much.
Yeah, so this would be also the thing.
It's,
And my questions are about simplifying this TrenchBoot ACL and inclusion in DTS potentially, the Shadow Tool Suite.
the problem is that to actually see the outcome, you need to try the secure launch.
Yeah, but maybe we could include the boot money for the. Does it make sense, or you think it's completely?
Maybe.
Okay. And then gathering the results the same way as the Shadow HCL.
Yeah, so that would mean, yes, that's one of the options.
Okay, that's it from me.
So that's it.
Thank you.
Thank you.